All right. Noble gases. We actually discussed the point that why do we call the noble gases as the noble gases? Or why do we call them group 0 and not group 8? We're going to discuss both points. Just begin with, they're all gases and they're all present in the atmosphere. That's why
Mm.
the phrase gases, we call them noble because they are completely unreactive. In fact, the two at the top of group, and we're talking about helium and neon, they don't react with anything in the periodic table, don't react with any element in the periodic table. For the rest of
Mm.
the elements, they have a few reactions, but that's about it, and they are fairly unreactive still. But reactions
Yeah.
doesn't mean they don't react with almost everything on the periodic table. They hardly react with two or three elements on the periodic table, and then they don't react with the rest. So
Yeah.
this lack of reactivity actually is connected to the phrase group 0 or to the word why do we call them noble. So unreactive means noble. Now, why do we call them 0? We call them 0 because they're unreactive, and they are unreactive because of the outer shell is full. Since they are present at the extreme right hand side of the periodic table, and that
Mm.
happens when all for the electronic configuration of the all of the electrons that are supposed to be added to a specific uh, period or to a specific shell that are already added, so their shell is full. For example, for first shell, we have a maximum of 2 electrons for the capability, and there are 2 electrons in helium. For the second shell, we have the maximum capability of 8 electrons, and there are 8 electrons in the outermost shell for neon. And for moving on for argon or krypton, so for most of them, at least they are stable with 8 electrons in their outermost shell, which means there is no tendency to either lose electrons or gain electrons or share electrons in a chemical reaction, so they don't react.
Yeah.
Actually, they do not need to react. The same is the reason which is explained in key point over here. First things first, we cannot call it group 8 because this element has 2 electrons in its outermost shell, and this is an exception for the rest of the elements.
Mm.
Because if we call it group 8, every element has to have 8 electrons in their outermost shell, and that's not true in the case of helium. Helium does not have 8 electrons in its outermost shell. All right.
Yeah.
We may call
Yeah.
it group 0. We can call it group 0 because of its unreactivity. And that's true. That's right. In reality, outer shells of argon, krypton, xenon, and radon, the last four, are not full. But since they have 8 electrons in the outermost shell, so they do not need to share or lose electrons or gain electrons in a reaction. So that's why they're still unreactive. All right.
Mm.
So
Yeah.
we tend to say that their outer shell is full or stable. And these lines, actually, these exact lines, starting from here to here, are a very good answer to why do we call them noble or to why we call them group 0 and not group 8. This is
Mm.
a perfectly good answer for this one. So mark these
Okay.
lines, remember these lines about noble gases, and they're going to help you a lot with both these questions: why noble or why group 0?
They
So,
asked in his exam, right?
right. That has been a part of paper 2 specifically in past papers.
Mm.
You'll find the same
Yeah.
question in past papers.
Okay.
Okay, moving on. Metals and non-metals in the periodic table. Now, the periodic table consists of some metals and some non-metals. Metals are usually present on the left-hand side. Non-metals are usually present on the right-hand side. But the division of metals and non-metals is not shown clearly in 4.9. There is a lot of uncertainty on the dividing line, but we can still work it out. Okay, so you're going to see this diagram 4.9. What we
Mm.
call this dividing line is that we call it a staircase. Notice this works like a staircase, like this. You will find that this dividing line is actually a staircase. Starting from the
Mm.
very first element of the third group, you can start with the staircase, and from there on onwards, everything on your left is metals, and everything on your right is non-metals.
Yeah.
Now, the ambiguity is about the elements that are present on top and bottom of this staircase. They may act as boundary line cases, they may act as both metals or non-metals, but apart from that, the rest are metals and non-metals purely. At this point in IGCSE, they're not going to talk about these elements in specific, being metals or being non-metals, they're just going to stick with the pure metals or the pure non-metals. So they won't talk about these elements much. You won't have to answer questions related to these elements. All right. So
These
it's
are
not going to be a
metalloids,
problem.
right?
Yeah, we call them either with the word metalloid,
Hmm.
or we call them with the word semi-metals. Either of the term is fine because this term represents that they have some properties of metals and some of non-metals, hence
Yeah.
the name metalloid. Now, a key point, you might have noticed by now that hydrogen does not really fit into the periodic table properly. Although it has one electron in its outermost shell, but it's not in group 1 because it does not have similar properties to group 1.
Yeah.
Okay. Yeah, it does lose one electron like group 1 elements does, but the chemical properties are completely different. Hydrogen is a non-metal. All of these are metals to begin with. So that's a huge difference to start.
Yeah. Okay.
So we're not going to place hydrogen on top of group 1. That's not the right way. The right way is to put hydrogen somewhere in between and call it a unique element, different from rest of the periodic table. All right?
Yeah.
Okay. So this creates the difference for us. Let's talk about the differences in the properties of metals and non-metals. There are many differences in the properties of metals and non-metals. We are just going to talk about two main differences, and we
Hmm.
are going to do that to bifurcate between metals and non-metals clearly. There will be other properties that we're going to discuss in the upcoming chapters, such as reactivity of metals or usage of metals. But for now, just two properties. The first one is going to be electrical conductivity. The second one is going to be acid-base character of their oxide. Let's start with electrical conductivity. Now, metals can conduct electricity. Non-metals cannot conduct electricity. The major reasons metal can conduct electricity is present in chapter 9. It's because they have delocalized or freely movable electrons. Metals have electrons that can freely move throughout the structure. They can conduct electricity. Non-metals do not have freely movable electrons. They cannot
Hmm.
conduct electricity. So this would be the major use of metals such as coppers in electrical wires. Non-metals do not conduct electricity because they don't have any electrons that are free to move. They don't even have any ions free to move. There would be just one exception, graphite, a form of carbon, or silicon, which will be able to conduct electricity. So yeah, whenever we put a rule, you might be astonished that chemistry puts a rule and then puts an exception in front of you. So that's keep gonna happening.
Hmm.
All right. So
Yeah.
all the non-metals do not conduct electricity except for graphite, which is a form of carbon, or silicon. These
Hmm.
are the two ones which are an exception from the rest of the non-metals. Now let's talk about the second property. They're going to touch these properties since the real clear view for these properties are explained in upcoming chapters. Now metals generally form basic oxide. What does a word basic oxide mean? A basic oxide is an oxide which reacts with acids and it forms salt. It may also form water along with it. So metal can form an oxide, a compound with oxygen, in such a way that it reacts with an acid and it forms a salt, it forms water along with it. This is also discussed in detail in chapter number 17. All right.
Yeah.
So if you do
Yeah.
not understand this at this point, don't worry. We're going to explain it a little later to you in a very different chapter where you to understand what the word basic oxide actually means. What does the word acid stand for? What does the word salt stand for? Yeah, you might have already learned from the previous classes, maybe from 8 or maybe from 7 or maybe from 9, that what acids or salts are, the very basics of them. But we are going to again clarify what an acid is or what a basic oxide is or what a salt is in terms of what you need to do at the part of O level. All right.
Yeah.
So they're going to discuss it furthermore that if the basic oxide is soluble in water, we may also use the word alkali. More of the hydroxides are soluble in water, so we call them alkalis. If acidic oxide is soluble in water, it will form an acidic solution. For example, some oxides are capable of dissolving in water or reacting with water to form acid, which is our very next topic. Take a look over here. Non-metals generally form acidic oxide. Now, exactly opposite to basic oxide, acidic oxides are the ones which can react with a base or an alkali to form salt in water again. So these oxides are exactly opposite to one another. Acidic oxides react with bases, basic oxides react with acids. They form the same thing, salt and water in every case, right? So this may happen with both of the structures. They might react with different species, the opposite species, to form salt and water. And the same thing is mentioned over here. Any acidic oxide, for example, a nonmetal, carbon is a nonmetal, it forms a compound with oxygen, commonly known as carbon dioxide. When it is dissolved
Mm.
into water, it is going to form an acid, which was explained over here.
Okay.
All right. So moving on, I'm going to clear the whole thing up. There are some exceptions to these rules. There are some metals which form different oxides, for example, amphoteric or neutral oxides, but we're going to clarify it in the acids and bases chapter, not over here. So let's keep some of these information as uh, just a prerequisite or an introduction to upcoming chapters, which we are going to
Mm.
later discuss in details in those chapters. For example, chapter number 9, for example, chapter number 70, so on and so forth. So, what are the exact properties of metals and non-metals that we can discuss at this level? Let's start with those
Yeah.
properties and be ready to face a lot of exceptions. We are going to come up with different rules, but for almost half of the rules will have a few exceptions. So it's better to remember the exceptions since exceptions are a common past paper question. Let's
Can
start
you
with the
repeat it?
properties of metals. I'm going to come up with examples to make sure that you understand what I just said. For
Yeah.
example, metals. All metals are solid except one metal on the list, and that is mercury, which is a liquid. That's what I
Oh
was
yeah.
talking about. As soon as
Mm.
we're going to put forward a rule, there will be an exception along with it. So the rule is all metals are solid. The exception is mercury.
Yeah. Okay.
Most metals have high melting and boiling points, but there would be some metals which will have lower melting and boiling points. All right.
Yeah.
So don't worry, we have exceptions to the rules. Metals are shiny. They have a proper luster. Luster means metallic shine. Whenever they
Metallics.
are polished or freshly cut, they show the shine. And you can actually see the shine in mercury too. Although mercury is a liquid, we do not need to freshly cut it. It can be easily converted into drops. Every drop will give a proper shine.
Mm.
Now,
Yeah.
metals are malleable, which means they can be hammered into shape. I'm going to come up with an example to make sure you understand. Metals, if taken into small pieces, and I hope you understand what hammers are.
Yeah.
Let's
Yeah.
suppose we take a hammer and we start hammering it. The piece would be flattened, right? This is known as malleability. Now,
Yeah. Yeah. Yeah.
malleability is a property of metals which can be really, really astonishing. I'm going to come up with a very specific example from your books or from O-level books. Let's suppose this is a piece of pure gold and the
Yeah.
piece is size of a matchbox. I hope you've seen matchboxes. They're really
Yeah.
of
Yeah. Yeah.
small size. If you
Mm.
start hammering a matchbox yourself, you don't use any machines, you don't use any sophisticated apparatuses, you simply use a hammer and you do it with hand. This piece of gold of the size of a matchbox can be flattened into a very thin sheet that can cover the biggest football stadium of the planet, which is a really astonishing fact. The football stadiums are really big, and just hammering with the help of a human arm and not using any sophisticated apparatuses, we can convert into a
Yeah.
very thin paper-like sheet, a sheet that can cover a big stadium, an entire stadium.
Mm. Okay.
And we're not using any sophisticated apparatuses. If you use some sophisticated machines or apparatuses, or better rollers, we can even roll it into a bigger sheet, much bigger sheet than that, right? So
Mm.
this is how
Yeah.
we can come up with the example of malleability. When it comes to ductility, you can take again a piece and you can actually push the piece into two separate directions, which means uh, pulling or stretching the piece. I would rather use the word stretch to explain it better, and it is converted into a very thin small wire like this.
Yeah.
This property is known as ductility. We can draw them into wires, we can stretch them into wires. And
Mm.
all the wires in your house, domestic wires or electricity wires, the wires you're currently using with laptops, cell phones, and their charger cables and all that, though we're going wireless, but we still use a lot of wires. So whether those are domestic wires, industrial wires are made up of metals, be it copper, be it aluminum, be it any other metal. They have the ductility, a capability because of which we can convert them into wires, and hence all of this is possible. So they are good conductors of electricity. They are also good conductors of heat. They can form ionic compounds. We'll see the detail in chapter 7. They are going to form positive ions. We are also going to see the details in chapter 7. Let's skip the details for now. Just remember the points and we're going to clear them a little later, one step at a time.
How do
Okay,
they ask this one in the exam?
which one? The last 2 points?
Yeah.
If you're talking about the whole thing, yeah, they can ask you to write three properties of metal, any three of your
Oh.
choice. You may
Mm.
be asked to relate a specific property to a specific usage. For example, if we're making electrical wires from metals, which two properties are at use? All right. So
Mm.
ductility is at use because we're converting it into a wire, and electricity is at use because we're using this wire for electricity conductance purposes.
Yeah. Okay.
Okay, then
Yeah.
let's say we take a metal pan and we commonly use those pans for the purpose of cooking food or frying or other purposes. Cooking pans are used for many different purposes other than frying as well. So which two properties are under use? So we took a sheet of metal. Of course, malleability is the property that we are using, and we're using good
Heat.
conductance of heat, right? So you can always relate some specific one property or a couple of properties or three properties related
Yeah.
to a specific usage,
Mm.
right?
Okay.
And if
Yeah.
along with the cooking apparatus, he tells you that the cooking apparatus looks very good or looks has a very good appearance, you may also need to add one more property to the list. That depends upon what kind of scenario he's giving you in the question.
Mm.
You're going to face
Yeah.
questions like those, you'll be familiar how the questions are asked, right?
Yeah.
Okay, moving on, non-metals. Now, non-metals are tend to be going to be the exact opposite of metals. So if metals had high melting and boiling points, non-metals tend to have low melting and boiling points. But since we
Mm.
had exceptions in metals, we're going to also have exceptions in carbon, exceptions in here. Carbon and silicon form compounds that have high melting and boiling points. So these are exceptions.
Mm. Okay.
Non-metals tend to be brittle. Brittle means whenever we try to shape them, they break. That's the very basic definition of brittle. When you try to reshape them, instead of getting into shape, they break. They don't
Mm.
have
Okay.
that same type of shine as metals. They're usually dull in their appearance. They don't conduct electricity, just carbon in the form of graphite and silicon are some exceptions.
Mm. Okay.
They are poor conductors of heat. Again, diamond, which is made up of carbon, is a very good exception because it's a great conductor of heat among all the elements. So there are a lot of exceptions, and every time you'll see brackets, you'll see exceptions. They can
Mm.
form both ionic and covalent compounds. We're going to discuss that in chapter 7 and 8. They tend to form negative ions. We're going to discuss that in chapter 7. So again, for the non-metals, they may ask you the usages. Exceptions are also very good questions in
Mm.
terms of both metals and non-metals. They may ask you about any exception.
Or they can ask the difference between, right?
Yeah, difference can also be discussed.
Mm.
Okay.
Okay.
So that's how the questions are posed. let's go with a few questions before we jump up to the past papers. What I'm gonna
Yeah.
do is that I'm gonna go with few questions from here.
Okay, can I answer?
Yeah, you are supposed to answer. I'm not gonna answer the questions. You're supposed to
Oh,
try. If you're not able to answer them, then I'm going to help you with it. All right?
yeah, okay.
Okay.
Um,
We are going to begin with question number two. The question number one is really easy. Locating an element on a periodic table or dividing them into metals and non-metals is really easy. So let's start with
mm,
two. Let's start with something that might give you a hard time.
with two,
Question number two, part A.
sodium. It's easy. So the first cell, I mean the shell will have. Is it fine if I say and you can draw?
Yeah, that's fine. All right.
Okay. So it has three shells. In the first shell, there are two uh, electrons,
Electrons, right?
and the second shell eight,
Okay.
and the third shell one.
Okay, good enough. What about silicon?
Okay, silicon. Okay. So the first shell will have two electrons,
Right,
and then eight
right,
and four,
right. Good. Moving on. Sulfur.
and then the first one will have two,
Mm-hmm.
eight, six.
Okay. Good, good. That's good. Though I've written the arrangements, but I hope you understand we're supposed to
Yeah,
draw
yeah,
diagrams.
yeah.
As soon as you see the word draw, I hope you know what to do.
Yep.
Okay. Moving on. Number three.
Uh, state the. Are you able to hear me?
Yes, I'm able to hear you. You have done previously correct, so I think it's easy for you to follow up or start off with fluorine. If
Okay.
you have the
So
periodic table in front of you, it should be easy, right?
yeah, wait. Just let me open one sec. One second. Yeah, okay. So I have to say the group number and the period number, right?
No, no, the electronic configuration, what we have just been doing, it's the same question. It's just that you need to tell me the numbers and not draw the whole thing.
Oh, okay. Okay, I get it
So
now.
it's the same question. That's why I was
Oh,
saying it should come easy to you.
yeah, 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 it's easy, bright. I did not understand so but now I okay. So the first I will have two,
Okay, good.
and then the second one will have seven.
Right. Next one, aluminum.
Aluminium. I think the first one will have two,
Right.
eight,
Okay.
three.
Right. Calcium.
One sec. Let me just do this one because it has four
Right.
shell. Okay. So first one will have two.
Mm-hmm.
Second will have eight.
Mm-hmm.
Third will have eight again,
Right.
and then two.
Good. Great. They are all correct. Moving on to
Mhm.
question number four. Number of electrons in its outer shell.
Outer shell means the last shell, right?
right? We also call
Okay.
it outermost shell. We also call it the last shell. We also call it the valence shell. So any of these words are fine, and they represent the same thing.
Okay. The first one. 1 second. Let me just find in the periodic table. Not able to find this one. Yes.
But if I tell you it's a non-metal and it's present at the right hand side of the periodic table,
Okay, 1 sec. Okay, right. Sorry. Okay, I got it. Let me just solve and then save.
were you able to find arsenic in there?
Um, no,
Not even on the right hand side of the periodic table?
no. I
Element.
found it. Yeah, I'm just trying to solve it.
So it's pretty easy. I hope you understand that the number of electrons in its outermost shell are equal to its group number. So go
Okay, okay, okay.
right up the
Yeah, yeah,
element and
yeah,
you'll find the group number.
yeah, yeah, yeah. Okay, okay, got it now.
So what are the number of electrons in case of arsenic?
How many electrons can group 4 can hold? Because
Four.
it's not.
No, no, they can hold more, but definitely that's not the point. The point is the number of the group is exactly equal to the number of electrons in the outermost shell. So group 4 will have 4 electrons in their outermost shell, 5 will have 5, 6 will have 6, so on and so forth.
Okay, can you solve the first one then? I'll just know.
Okay, it's arsenic and the symbol is AS. So what I'm going to do is that I'm going to jump right back to the page where we had the periodic table. Okay,
Yeah.
this is the periodic table. Now we're going to try finding AS. You'll find AS over here. We're going to go
Yeah.
straight to this, and there you go. 5 electrons. It has 5 electrons in its outermost shell. That's as easy as it is.
Oh, okay. Okay, I got it now.
Great. If you got it now, I think you can solve the rest of the questions
Yeah.
very correctly and quickly. So let's start with the next one, bromine, Br.
BR.
How many electrons are there in the last shell
It's
or the outer shell of Br?
non-metal, right?
Yes, it's a non-metal.
7.
Great. Tin, Sn.
4.
Good. Xenon, Xz.
XC. Yeah, okay. It's 0.
No, they can't have zero. We call them zero, but the number of electrons in
8.
their outermost shell, yes, that's correct. Eight, eight. Okay, so I'm going to give you some more for practice. What about barium, the symbol for which is Ba?
BA. Okay. BA. It's 2.
Good. Then the next one is rubidium, the symbol for which is Rb.
It's 1.
The next one is going to be sulfur, the symbol for which is S.
Sulfur.
Questions like
Uh,
these are also definitely a good practice to go through the periodic table where you will be more familiar, you'll be able to find elements easier and more quicker the more you get familiar with the periodic table. So exercises
six.
we six, very good. Next one on the list is gallium, and the symbol of gallium is Ga.
Ga. It's 3.
The next one on the list is lead, and the symbol of lead is Pb.
Pb. It's 4.
4. The next one on the list is flavarium, and for flavarium, the symbol is Fl.
Uh, Fl. I'm not able to find it.
Try looking at the bottom of the periodic table as a hint. You are not going to find it at the top. You'll find it at the bottom of the periodic table. I'm not specifying left or right, but the bottom would definitely help.
Oh, okay, I got it.
Good. And the number is,
Uh, is it 3?
is it? I don't think that's 3. Let me check.
No, 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 it's 2. It's 2.
What? No, it's not 2 either. Oh, I see. You probably don't have flavarium and on the recent page. So let's look at the periodic table over here. This is the periodic table. You will easily find Fl.
Yeah. Oh,
Use
not
this one,
using.
please. This one is the complete periodic table, the best periodic table you can have. So yeah, this one is going to help you out. Fl.
Where is that? Okay, yeah, it's 4.
It's 4. Good. The next one on the list is tellurium. The symbol for tellurium is Te.
Okay. Te. Hard to find them. Te.
Yeah, that's a good practice. There's so many symbols out there, more than 100. So if you need to look for the exact one for yourself, how can you do it in a quicker, efficient way? So we let the student familiarize herself or himself with the periodic table more and more. So he's going to be quicker every time he's going to
Yeah,
make an attempt on the question.
yeah, it's 6.
6. The last one on the list is astatine. All right. And the symbol for astatine is AT.
87.
7. Good, good. I think now you're good with the practice and you will be able to find the element and do it accordingly. So we're going to just simply move on to the next question. All right. This question refers to the electronic configurations below. Don't worry if some of these are unfamiliar to you. All of these electronic configurations are of neutral atoms. Now, if you look at these electronic configurations, let's start with part A. Explain which of these atoms are in group 4 of the periodic table.
Yeah.
Now, the configurations may sound a little bit scary. Don't worry about that. That's not the point. The point is that you get the answers of these questions correctly, and you already know how to do that. So, part A, group 4.
It's carbon.
You're not supposed to identify the elements. You're supposed to
Oh
tell
yeah.
me
Okay. Okay.
from these alphabets which one lies in group 4. And
Okay.
of
Okay.
course,
So
they are using the term atoms. That means it's a plural. There are more than one.
okay.
So the answer to
So
this one is
so the group number is 4,
right.
and the period number is 2.
No, you're not supposed to tell me the group number or the period number. Choose out of these alphabets which alphabet will lie in group 4.
Oh,
Put the
okay.
periodic table aside. You're not supposed to take help from the periodic table in this case. Work out these electronic configurations and tell me which of these elements A, B, C, D, E, F, which of these elements or atoms will be a part of group 4 of the periodic table as per their given configuration. Don't try to work out the element. That's not the right way to do it. Just simply look at
Okay.
the question from my screen. Don't take help from the periodic table. You can do it
Yeah.
simply from the screen. Go ahead.
Okay. Um. mm, Oh, it's E.
E,
Yeah.
group 4, not period 4, group 4. We have been doing it in the recent questions. Okay, let me give you an example. This is group 4, which means the last number has to be 4. The last number is 4 over here. So one of the possible answers is A. Which one is the other possible answer?
F.
F. Now you're doing great at it. Remember, group means the last shell electrons, and of course, that's the last number on the electronic configuration. Let's go for part B. Which of these electronic configurations represents carbon? Now you can take help from the periodic table.
Okay.
So among A
So
to F, which one is carbon?
it's E.
No, of course not. Try
Oh,
again.
it's A.
Carbon. Carbon, not calcium, carbon. All right.
A.
So it's
Yeah.
A. Good. Part C. Explain which atoms are in period 5 of the periodic table.
Okay. 5. It's C.
Great. Since it's atoms, so the answer must have more than one alphabet. So
It
one
can
of
be
them is,
D as well.
it can be D as well. Great. Let's
F.
come to,
F.
no,
Oh
F
no,
is
no,
not the
no.
answer. Right. And
Yeah,
now
yeah.
you know why F is not the answer. So we're gonna discuss that. We're gonna move on to part D. Explain which of these electronic configuration represents an element in group 7 of the periodic table. Group 7,
Group 7. It's C.
C. And why? Since we're going to explain it too, why?
Because the group 5. Because there are 5 values.
No, we are only explaining for group 7. It does not matter how many values are there. That is for period calculation. We are talking about part D. Your answer is actually a pretty good answer for part C, but not for part D. Now I'm asking you for the answer to part D.
Mm,
Group
mm,
7. Why are you saying it's in 7?
Oh yeah, okay. Uh, because the last number is 7.
Perfect. That's a great answer. Move on to E. State which of these electronic configurations represent noble gases. Configurations, which means more than one answers are actually noble gases. Which ones are noble gases?
Mm, it can be it can be B.
Great. One of them is B. What's the other one?
Um, A.
No, that's not
Uh,
right. Noble gas means how many electrons it's going to have in its outermost shell?
uh,
How many electrons does B has in its outermost shell?
B. It has 8.
So which other one has 8 electrons in its outermost shell? That's definitely going to be the answer.
D.
D. That's easy as it is. So this one is a noble gas because of this. This one is a noble gas because of this. Since we were only supposed to tell the names, we're not supposed to explain this question. State means you just tell them the name. State means tell them the name. Explain means give them a one-liner explanation. So since it's
Mm,
state, write just B and D and you get the mark. F part.
yeah.
State the name of element E and explain how you arrived at your answer. Now, for this specific question, you'll need the help of the periodic table. So take the help
It.
from periodic table, all that you need, and then state the name of the element.
Okay. Um, it's Ca.
That's the symbol, that's not the name. You're not gonna get marks
Oh,
that way. They're asking
okay,
for the
okay.
name.
Yeah, yeah, okay. It's calcium.
Calcium, very good. And how did you arrive at your answer?
Periodic table.
You cannot write periodic table as an answer. You need to come up with a logic,
Because oh yeah, okay, okay, okay. So because the group number is 2 and it belongs to the wait,
it belongs to which period then? Group number is 2. What's the number of period it has?
4.
4. And that's how you landed at the right element because it's exactly was period number 4 and group number 2. And the only element at that position is what? Is calcium, right?
Hmm. Yeah.
That's a very good explanation to this question. Let's move on to part G. Part G says, state how many protons are present in an atom of element F. Also state the name of the element,
How many protons?
right?
Oh,
Now you need a higher order thinking skill. First, you need to locate the element, its name, and then from its atomic number or proton number, you'll get the number of protons. Tell them what the number of protons are then.
I don't know this one.
Okay, let's just tell me the name of this element. That's about it.
Okay.
What's the group number for this element?
It's group 8.
F.
Oh,
Come on, the
yeah.
last number in F is,
4.
so it's going to be group 4. How can it belong to group 8? Come on, we have been practicing this for so long. You can't make a mistake now. So the
Like,
last number is
yeah.
4, so it is group number 4. How many numbers are there in total? So the first
There
number
are
is 2, the second number is 8. In that way, how many numbers are there?
6.
So the period number is,
6.
so try finding which element lies exactly under the position of period 6 in group 4.
Okay.
Can you locate the element? Okay, I'm going to go back to the periodic table and I'm going to help you with it.
Is it silicon?
No,
No.
period 6, group 4, period 6. Okay, which one is group 4? I'm going to use red color this time now. All right. So group 4 is this. What's
Yeah.
period number 6? Period number 6 is this. So move all the way in this period down to this group. Which element do you land at? There can be only one element in a specific group in a specific period location. And that
Yeah.
element is, the name of the element is,
Uh, it's
do you have a periodic table that contains the names? It's
yeah, yeah,
usually
yeah.
at the start or the end of the book.
It's lead.
Lead. It's pronounced
Lead.
lead.
Yeah.
All right. So yeah,
Yeah.
lead. Okay. Now you know it's lead. So since you're using a different periodic table, the one at the start or end of the book,
Hmm.
just next to lead, there are two numbers. One of them is the proton number, which is the number of protons, which is usually the smaller number among both. On one of them is the larger number, which is the mass number. You need the smaller number. Smaller number is the number of protons. And the number of protons in this case is,
4.
no, that's not it. Come on. Number of protons. The smaller number
Number.
written next to lead is, which periodic table you're using, by the way?
It's 82.
82. Now you're right. Good, good. 82 is
Can
the
you
number of proton.
can you explain me this question once again?
Sure, sure. What I'm going to do is that I'm going to clear everything up and I'm going to move a few steps back on the periodic table. Actually, I'm not going to use this periodic table. Do we have the periodic table at the start of the book or at the end of the book? End, I guess.
It's and yeah, it's page number 320.
So let's move all the way to page number 320. This one. And I'm going to rotate this page a little bit. Where are my rotations? Okay, let's use it like this. I'm gonna rotate the view, gonna fit the width. There you go. Now we can see the whole periodic table. Using this periodic table is a very good idea since you're going to get a similar one like this in exams. Okay,
Mm.
so now they told us that there was some specific configuration like 2, 8, 18, 32, and then there was 18 and then the 4, something like that. Now,
Yeah.
from these digits, we got the idea since there are six numbers, it's present in period six. Since the number at the end is 4, so the group number is 4. So we started going down group number 4 and we started coming across period number 6 till we landed on the specific element that is lead. All right. Lead has
Yeah.
the smaller number 82, and this is the proton number. Remember, we started the chapter with it. At the very
Mm.
start of the chapter, we told you this is the number of protons. This is also the number of electrons. But in order to get number of neutrons, you subtract the smaller number from the bigger number, you get the number of neutrons. So the number of
Yeah.
protons are 82. So its Pb, its lead, its period is equal to 6, its group is equal to 4, and then the proton number is equal to 82, right?
Yeah.
That's how we do it. It's as simple as this is. The smaller number written next to the element is the proton number.
Mm.
I guess you definitely need more questions like this. So
Yeah.
I'm not going to go to the previous page. I'm going to stick to the same page so that you have the whole periodic table in front of you and you can work your way out. So I'm going to give you a couple of questions like this. So again, I'm asking you two things, the name of the element and the proton number. You've also
Okay.
forgotten my tip. I gave you an easier tip to find out the proton number. You've got that tip. So after this question, I'm going to repeat my tip again. The tips are
Okay.
there for you to work your way out easily in the exams. Let's first locate the element. So I'm going to help you with it. What's the group number for this element? Group number.
Uh, 6.
Very good. What's the period number for this element?
It's 4.
4. Great. Now, if you go with period 4 and group 6, which element you land at?
Wait, wait. I will do. I will do. I will do. Uh, it's lead.
That was period 6 and group 4. This time it's the opposite. It's period 4 and group 6.
Oh, oh, okay, okay, okay.
We just did lead. Why would I give you different numbers for the same element? They can't be different.
Okay, I got it.
So the name of the
It's
element is
selenium. Selenium?
selenium. Right, selenium. Something that is present as a common part in anti-dandruff shampoos. Okay,
Oh,
now let's talk about the proton number of selenium. What's the proton number in selenium? Number of protons?
34.
34. Now, one way to look at it is this, looking at the element and then going with this number. Now, you have forgotten the tip. I told you, you can add all of these numbers to get the proton number. So proton number is equal to 2 plus 8 plus 18 plus 6. So you can even use the calculator for this one, and the answer you'll land at is 34, the same number written over
Yeah,
here.
yeah.
You forgot the tip. You never needed to go with the periodic table. Yeah, you need to go with the periodic table to locate the element, but for proton number, you can say it from adding the number straight here.
Oh, okay.
Okay. Now,
Yeah.
another question. This time I'm gonna use black. Okay, so we can keep the difference between the questions. So it's 2, 8, 18. Oh, that's a little confusing.
Hmm?
Wait a second.
Okay. Okay, so the it's group number 1,
Great.
and it's period number 7.
No. Think again.
666.
6. This time, instead of locating the element, tell me the proton number first. Add these up first.
Okay, 2 plus 8 plus 18 plus 18. It's 55.
Great. Now locate the element and tell me its name.
It's calcium. No, 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 no. Okay, okay. Is it calcium? No. Okay, wait. Let me just do it.
Calcium is present in group 2, so that's not possible.
Yeah, okay.
If you don't know how to pronounce it, simply spell it out. That's
Yeah, yeah,
fine.
okay. So it's group number 1 and 3 minus 6. Oh yeah, okay. I got it.
And the name is?
Calcium.
It's called cesium. And yes, you're right. There it is,
Calcium.
right
Okay.
there.
Yeah.
So group number 1, we go all the way down the group and across the period, and there you go. You located the element.
Is it fine if we as you said, after like finding the number of protons, we can see in the table like the proton seats 55, 56, so we can identify it's this one.
Yeah,
We can
you
run.
can identify it any way you want to. If you want to locate 55 and you come right across 55, and then from there on onwards, you go with the name of the element, it's entirely up to you. You can pick any of the methods. There are multiple methods to go with it. Either one is fine.
Yeah, yeah, okay.
All right.
Yeah.
So I hope you do get the point since it's about time. So let's just stop right here.